Hello guys, welcome back. So in this video we'll be discussing about the trusses, which is the fourth problem. We'll be creating the structural part for the given problem. So at the end we'll be discussing how to get the results for nodal displacement, reaction forces in each member, and stress in each member. So visually this would be our working part, which is the red dots are the key points. Basically, we'll be creating 5 key points, and the red lines basically tells that those lines are of same cross-sectional area, so which is 11600 mm square, and the blue lines says that they are from different cross-sectional area, which is 7750 mm square. And we'll be defining loads on these two parts. We'll be constraining some part of coordinates in these 2 points, which is along ux and ui part. And at this point, we'll be constraining the force which will be acting around the downward moment, and the value is 667,000. So yeah, let's discuss it completely on the ANSYS window. Welcome back. We'll be doing the structural part over here in the ANSYS. So the first step, we'll go to preferences, select the GUI as structural and click on OK. Then go to preprocessor, the element type. We'll add the element type as link and 2D spar 1. So make sure these two are selected. Click on OK and close it. So we'll add the real constant now. Go to real constant, add. So according to the question, we are given 2 areas. So the first area will be naming it as real constant set number as 1, and the area would be 7750. Click on apply. So we have two real constant over here because we have 2 areas mentioned in the question. So the second area would be 11600. So according to the question, we have 2 areas. So we'll be having two real constant set numbers, and we'll be declaring over here. So click on OK. So those two sets are being defined over here. You can close it. Then go to material properties. Go to material models. So we'll be adding material model over here. According to the question, for the entire truss follows one structural model, so which is given by the question itself. You can easily find out by the given Young's modulus, which is just 206 gigapascal. So by seeing that, we can figure out how many models we'll have to create. So right now for this particular question, we'll only be creating one specific material model. So by going to structural, linear, elastic, and isotropic, the Young's modulus, which is EX, would be 206 gigapascal, which is 206 E3, and the Poisson's ratio PRXY value would be 0.27. You can click on OK. So it's added, close it. Then we'll be creating the points for the necessary truss model. So go to modeling, create key points in active CS. So the key point number for initial coordinate would be 1. First key point would be 0, 0, 0. Click on apply. So the second would be, so actually we'll be going on a inverse W direction, which is 1, 2, 3, 4, and 5. So the first point is 0, and the second point would be up, which is 2, comma, second point would be 2, and the x coordinate for second point would be 2750, and the y coordinate would be 1800. Click on apply, and the third point would be 2750 plus 2750, and the y coordinate would be 0 right here, because the third point would be somewhere around in the x axis itself. So click on apply, and now we'll be creating the fourth point, which is 2750 plus 2750, and again plus 2750. So for the y direction, we'll be adding to 1800. So this would be a fourth point. The last and fifth point would be the 4 times of 2750, which is I'll be adding 2750 again for the existing coordinate, and this 1800 will be cancelled, and as it is like it's on the x axis itself, so we'll be defining 0 for the y coordinate, y coordinate, and just click on OK. So we have the required points, which is the inverse W kind of structure. Now we'll just connect those with a line. Going to lines, straight line. So we'll be connecting the first key point to second, second to third, third to fourth, then fourth to fifth. After this, we'll be connecting first to third and third to fifth, and at last 2 to fourth. So this completes our modeling part of the given trusses problem. So yeah, now we'll be moving on to meshing part. Go to meshing. So here we'll be working with we'll be going to the meshing part by starting with mesh attributes. So in the mesh attributes, we'll be going with picked lines. In picked lines, we'll be picking first these two lines, because these 1, 2, and 3, 4, 5th, 5 lines, 5 trusses have different real constant set number, and these two specifically has different constant set number. So we'll be defining those for these two first. So the real constant set number for these two would be 1 as it is. Click on apply, and for these leftover trusses part, we'll be defining real constant set number as 2, and finally we'll click on OK. And now we'll be going to size controls, manual size, lines. So we'll pick all lines. The number of element division for this particular trusses would be 1. So click on OK. We should get a visual for the structural part like this. So next we'll go to mesh, lines, and just click on pick all. So this completes the meshing part for this particular problem. Now we'll be going to the next part, which is loads. So we'll be defining loads in particular sections like the 5th point, 3rd point, and the 1st point. So let's define those. Go to loads, define loads, apply structural displacement. So on key points. So in this particular 5th key point, we'll be assigning a load of, the displacement load of ux and uy. So the DOFs to be constrained would be ux and uy. So the displacement value for this would be 0, and clicking on apply, this should be the symbol you should be getting. And for this particular third key point, you should select it, and here the DOF which should be constrained would be ux, only ux, nothing should be selected else. And the displacement value for this would be again 0. Click on apply. So this should be the part you should be getting. Click on OK. Then we'll be assigning force over here on at this key point. So on key points, click on this key point. OK. So the force in the given problem is acting along negative y direction, so we'll be taking it as Fy, and the force over moment value would be 6 minus 667,000. So the negative value is taken because the force is acting along the downward direction, so this should be noted, and click on OK. This completes the entire modeling, creating and meshing, and overall after defining loads, this should be the structure you should be getting visually. Then we'll just close this loads part, go to solution, solve, and current ls. We'll be verifying our solution. If we get a pop-up like solution is done, then we'll just close it and move on for getting the results. So according to the question, we'll have to find out 4 parameters, which are nodal solution, reaction solution, element, like the force and stress in each particular element. So these are the 4 parameters we'll be listing out, or we'll be showing it to the examiner. So we'll have to go to the general processor part. Here we'll have to define 2 element table, which are force and stress. So now here we should go to element table, define an element table, add it. So here in the user label for item, as per the given question, as per the given questions, there are 2 parameters, stress and force. We'll be adding 2 tables here. For stress, just write it as stress and just select by sequence num. Make sure ls is selected on the right side of data item, and just enter ls comma 1. So this should be the defining part for stress, and click on apply. Then continuously we'll be creating for force. Just define the label as force, go to by sequence num, select it, and SMISC should be selected with comma 1, and this should be the defining table for force. Click on OK. You can verify if it's added or not by here and close it. So now if we have done with defining the table, we'll be continuously getting the results right now. So go to list results. Before going to list results, you can also plot the results to visually get how the structural part is going. So go to counter plot in plot results, go to nodal solution. In nodal solution, inside nodal solution, go to DOF solution. In DOF solution, go to displacement vector sum, click on OK. So the DMX and SMX value will be displayed. You can note it down, and this will be the part, and we can list the results by going to list result, and here in list results will be first getting out the nodal solution. In nodal solution, DOF solution. In DOF solution, we'll be getting displacement vector sum. Okay. So in this, we'll have to be noting those values of maximum absolute values, node values, and the values in this table. So you can just take a snapshot, close it. Then we'll be getting the reaction solution. Select all items. Okay. So we'll be getting the values for reaction solution. Make sure you enter and note it down with the proper units. Next, finally, we'll be getting the results for element table for stress. Click on OK. So the minimum and maximum value would be provided. You can note it down. And for force, again, we can get the minimum and maximum values for that as well. So according to the question, we have listed all the results for nodal reaction and stress and force. So this completes the problem for stresses, particularly the fourth one. Thank you for watching.